Day 372 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2284, sender with largest word count. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You have a chat log of n messages. You are given two string arrays, messages and senders, where messages of I is a message sent by senders of I. A message is a list of words that are separated by a single space with no leading or trailing spaces. The word count of a sender is the total number of words sent by the sender. Note that a sender may send more than one message. Return the sender with the largest word count. If there is more than one sender with the largest word count, return the one with the lexicographical largest name. Note, uppercase letters come before lowercase letters in lexicographical order, meaning Alice with a capital A and Alice with a lowercase a are distinct. So, let's go ahead and take a look at example one now that we understand what the question is asking. So in example one, we have the input messages hello, or excuse me, the input messages equals an array of strings. First string being hello user 2, second string being hi user 3, third string being wonderful day Alice, and the fourth string being nice day user 3. Senders equals an array of strings Alice, user 2, user 3, and Alice. The output is Alice. Explanation says, well, the output is Alice because that means Alice sent the most messages. And the explanation says Alice sends a total of 2 plus 3 equals 5, or excuse me, the most words. Alice sends a total of 2 plus 3, which equals 5 words. User 2 sends a total of 2 words. User 3 sends a total of 3 words. And since Alice has the largest word count, we return Alice. So let's go ahead and go through this example a little bit deeper so we can really make it make sense, right? So we have the input string the input messages is an array of strings. The first string is hello user 2, right? So this corresponds to the first string and senders, right? Or which is the first name, which is Alice. So this means Alice sent hello user 2. Then the second string is hi user 3. So this is messages index 0. Excuse me, this is messages index 1. So we come to sender index 1. We look at sender index 1. That means that was sent by user 2 because the indexes correspond. So user 2 is at sender's index 1. That means user 2 sent the message at messages index 1. Boom. So now we're at messages index 2. So then we come down to sender index 2. That means it says wonderful day Alice. That means that sender's index 2 is user 3. That means user 3 sent the message wonderful day Alice. Then we come to index 4, which says nice day user 3. And we come to index 4 of senders, it says Alice. So that means Alice sent the message at index 4 of messages because Alice is at index 4 of senders, right? So each one of these indexes correspond to the message that they sent in the messages index. So once again, we have Alice at index 0. So this message right here at index 0 was sent by Alice. We have user 2 at index 1. So this message here, index 1, was sent by user 2. We have user 3 at index 2. So this message right here at index 2 was sent by user 3. And we have Alice at index 4. So this message at index 4 was sent by Alice. So as we can see, Alice sent the first message, right, at index 0. So we count the words. We have 1, 2 words right here. Alice has sent 2 words so far. Then we come right here and we can see the last message right here has 3 words, and that was sent by Alice, right? So altogether, Alice sent 2 plus 3, which equals 5 words. She sent 3 words right here, and she sent 2 words right here. Whereas user 2 at index 1 sent this message. This message has 2 words, right? It says User 2 sends a total of 2 words. Then we come right here to user 3 at index 2. So we check index 2. Index 2 has a total of 3 words, right? So that means user 3 sent a total of 3 words because user 3 is at index 2. And since Alice has the largest word count, we return Alice. So that's how we got the output Alice. We're just counting the number of words that each sender sent. Now, I hope that made sense to y'all, but just in case it didn't, let's go ahead and take a look at example 2. Example 2 is a little bit easier to understand because there's not as many senders, right? There's only 2 senders. So let's go through it. So in example 2, we have the input messages equals an array of strings. First string being how is LeetCode for everyone, and the second string being LeetCode is useful for practice. Boom. And then we have the input senders equals an array of strings, which is the names Bob and Charlie. Output is Charlie. Explanation says Bob sends a total of 5 words. Charlie sends a total of 5 words. Since there is a tie for the largest word count, we return the sender with the lexicographically ordered larger name. So in this case, Charlie, they both sent 5 words, right? Bob is at index 0. That means this message at index 0 comes from Bob. How is LeetCode for everyone, which has a total of 5 words. Excuse me, 1, 2, 3, 4, 5, right? Then we have the second message. LeetCode is useful for practice, which is at index 1. So Charlie is at index 1, corresponding index 1 for senders. That means Charlie sent this message right here. LeetCode is useful for Bob, is useful for practice. Sorry. So as we can see, they both have 5 words, right? But since we want to return them with the lexicographically largest name, and Charlie has the lexicographically largest name, we're going to return Charlie since it's a tie, like it says right here. Since there's a tie for the largest word count, we return the sender with the lexicographically larger name, which is Charlie. So I hope that made sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's get started. Now, the first thing we need to do is we are going to create our dictionary, which is going to store the total word count per sender. So for that, we could just say bar. We could call it dic, short for dictionary, and we can set that equal to a dictionary with a string, colon, integer, and we can initialize it like this with 2 parentheses. Now we need to iterate through each sender and corresponding messages. So for that, we're going to say for, open up the parentheses, I, comma, val. Then we're going to say n senders dot enumerated. And what this enumerated is going to do is going to get us both the index and the element of that corresponding index. Then we're going to open up the brackets, and now we need to count the number of words in the current message and add to the sender's total. For that, we're just going to say dict square bracket val, comma, default, colon, 0. Then we're going to come outside of that, and we're going to say plus equals messages, square bracket, I, period, components, open up the parentheses, separated by colon. Then we're going to say it's separated by a blank space, right? So we put a blank space in between these these quotation marks to represent each word, so we know, because it says right here words that are separated by a single space. So this is how we know where each word ends. But then we're not done yet, because we're going to say dot count. So then we're going to add that count so this value is going to represent each sender in the array, right? And then the count is going to get the number of words that each sender has, and it's going to add it to this default value, and we're going to start from 0, and that's how we're going to keep count of the number of words. Now we need to sort the dictionary into an array by descending word count. So for that, we're going to come right here. We can declare a variable called r and set that equal to dict.sorted, open up the parentheses, say by colon, open up the brackets. We're going to say $0.value greater than $1.value. Boom. Now we need to filter all the senders who have the same highest word count. So for that, we're going to say var new r, and we're going to set that equal to an r to r dot filter. Sorry, y'all, filter. And we're going to open up the brackets. Open up the parentheses, then open up the brackets. And we're going to say $0 dot value equal signs r dot first question mark dot value. Boom. Now from the top word count senders, we're going to sort them by name in descending order. So for that, we're going to say new r dot sort, open up the parentheses by colon, open up the brackets. We're going to say $0 dot key, and then we're going to say it's greater than $1 dot key, just like that. And now we need to return the lexicographically greatest sender among the top word count senders. So for that, all we have to do is come right here and say return new r dot first square bracket dot not square bracket, first question mark dot key, and then it's optional, so we can say question mark, and if nothing's there for optional, we could just return a blank string like that. So that's all she wrote, y'all. Not that much code at all. Let's go ahead and give it a run. Make sure it runs properly before we submit it. Oh, we have an error. Separated by, sorry y'all. So let's see, I spelled it wrong. This should be A. Sorry about that. Let's run it again. Sorry for the typo. Let's see, and it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it, so we can see what this time is looking like. Ooh, 240 milliseconds. I don't know what that means. I don't know what that %, means, but we'll take it. The memory's looking good, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.